So work, maybe pay isn't the best indicator of how much work is completed. What about time? Is time always a good indicator of how much work one does? Sometimes. Can someone tell me, like, when might be a good, or sorry, can someone give me an example of when time is a good indicator of how much work is completed? Yeah, go for it, Dea.
Like if there's two people who maybe have the same like level job and it pays the same, but one of them gets to work at like 6 a.m. and stays till like 8 p.m, and the other gets there at like 8 a.m. and stays till like 4.
Okay.
I think that's a pretty good indicator.
Gotcha. Is there a example in which time wouldn't be a great indicator? Annie, go for it.
Well, I know personally, sometimes I procrastinate my homework. So like an assignment that takes me 15 minutes, I'll spend like 3 hours on. So I'm not doing more work. I'm just being lazy. So
Yeah.
Someone could get the same amount of work done or even more work done in less time. But that doesn't mean that I'm doing more work.
Okay. So time isn't necessarily super helpful in figuring it out, right? I will confess to you guys. Sometimes I have a dual monitor setup. It's actually really helpful for teaching, like having like the assignment over here and then the grade book over here, and I can kind of transfer it over. You don't care about that. It is sometimes unhelpful because I'll have like a video running on the other screen and I'm like, oh yeah, I'm getting stuff done. Okay, what was it? Oh yeah, that's the thing I was doing. Okay, gotcha. I get back to it. I find it a little bit more enjoyable, but just like Annie was talking about, I don't get nearly as much work done. Like it'll take me like an hour for something that could have maybe probably taken me 30 minutes. I'm recording class today. I've just confessed to all of the classes is what I've done. Anyways. So yeah, time isn't a super important factor here. I'm going to give you an example now, and I want you to tell me, how do we know who does more or less work? Because this is related to class, like physics. Don't worry, but I think it's fun nonetheless. Okay. Before I move on, I want everyone to understand this is completely hypothetical. I have not done this thing. When I say there is an assignment, it's a fake assignment. I haven't given it to you. Please don't freak out. Because when I'm in person with you guys and I do this, everyone's like, huh? Because half the people didn't hear the caveat at the beginning. Okay. I'm not doing this. No one has done this. Hypothetically, I have assigned you a 1-page paper. I'm not going to do this right now. Okay. I have assigned everyone in class a 1-page paper. Okay. Now, I'm going to split the class in half as if we were in person. Let's say the left-hand side of the class, if you were actually seated in person, you guys are great. You're diligent. You get it done in one evening. You spend the evening writing your 1-page paper. It's due Friday, but you're like, you know what? I'm great. I'm going to get it done. You get it done. Good job, left-hand side of the room. If you want to be the left-hand side of the room, you can identify that way. That's fine. The right-hand side of the room, they say, you know what? I'm going to take my time. It's due Friday. I'm going to work on it each evening. So it's assigned on a Monday, let's say, and it's due on Friday. So they spend 4 evenings working on it. They get it done by Friday. They turn it in. Obviously, the people that got it done left-hand side of the room, they got it done in one evening. They turned it in Friday. Right-hand side of the room took them 4 evenings to complete it. All of you, the entire class was great. You wrote it to about a similar quality. So it's not like the people that wrote it over the 4 evenings wrote kind of like half sentences run on sort of thing. Okay. Who does more work? The left-hand side that wrote it in one evening, or the right-hand side that wrote it over 4 evenings? Take a moment, consider. Who does more work? Daya's already put her flag in the sand. Abby, you wanna explain?
It like depends. That one evening could have been like 4 hours, and then the 4 nights could have been like 10 minutes each.
Well,
so
let's
you
say,
gotta know the time.
Yeah, so let's say they take every evening is the same amount of time. So like left-hand side of the room, I don't know, spend an hour writing the 1-page paper, and the right-hand side of the room spent an hour every evening writing it.
Yeah.
So they spent 4 times as long to write the paper. Dea, you want to battle? You want to battle Abby and her answer?
Well, I was just thinking, like, if they spent 4 times as much, not only are like their cumulative amount of time bigger, but they also had to stress out about it all week, and that's kind of worth.
Well, I mean, they didn't. Neither of you stressed.
Okay.
Like the people that actually wrote it over 4 evenings, they said, you know what, I'm just going to take my time.
But like you still have to be thinking about it. Whereas if you get it done right away, they're just like, okay, I'm done, put it out of my mind. Because even if you're like, okay, I'm going to be super calm about this and not stressed, I would stress no matter what happens. So I think the right side would do more work, even if they put in like only a little amount of time each day.
Okay.
And so cumulatively it would be 1 hour.
Okay. Angelo has an interesting answer here. He says, you're doing the same amount of work, but in different time intervals. Davey, you had you also asked if it would be equal. Why do you think it might be equal? Is it similar to Angelo's answer, or is it slightly different?
Well, yeah, because you're still doing it's still only a 1-page paper.
Okay.
So it's equal. I don't know, in my mind.
I, as the teacher, I would like you to consider things from my perspective. I know that might be hard. I'm like an alien from another planet, especially on Zoom, right? Like, what the heck, dude? What do I see? Do I see similar amounts of work, or do I see very clearly different amounts of work? Everybody turned it in on Friday. Everyone wrote the 1-page paper. Everyone essentially wrote to the same quality. What do I see? Seeing a couple answers in the chat saying the same. Are we of consensus that I see like similar amounts of things? Does it really matter to me who took 4 nights versus 1 night? Not really. Now, Abby and Dea, you have hit upon something that I'm going to come to in just a moment. But in terms of the amount of work, everyone's actually done the same thing. You completed the assignment in the amount of time I specified. I don't really see a difference. Now, the quality could be different, right? Quality would be a part of it. If someone just wrote 4-word sentences the entire time versus someone who's like changing their sentence length and using different like higher level words and lower level words, whatever, right? That would change the amount of work, sure. But if it's all about the same, I can't really tell, like you're all getting, I don't know, solid 80s, right? 80% on this paper, then you would have all turned in the same amount of work. Time wasn't super important to this. This gets back to Annie's example, right? I could have just taken my time and I did the same quality, right? I got all my things graded versus I got them all graded in 30 minutes. So I can change this around, the time element. But the product in the end, what is completed, is the same. What about level of effort? Is that the same? Or is the time element now important there? Like how quickly someone got it done? Or maybe how hard someone worked? Is there a difference there? I'll open it up to the floor. What do you think about effort? Who exerts more effort to complete the assignment? Left-hand side of the room, 1 evening. Right-hand side of the room, 4 evenings. Who exerts more effort? Indiana, you say left-hand side of the room. Could you give me a reason? Why might left-hand side exert more effort? Ooh, we are split. This is fun. And you guys have good reasons too. I like your reasoning. Okay. So some people are saying because they worked longer, they're exerting more effort, right? That maybe because it's like the discipline to get it done each night, right? Some people are saying that, well, because you did it in a quicker amount of time, right? You had to type faster. You had to find your sources quicker, read faster to find out the important information, probably. I'm going to leave it open for a moment. I'm going to say that both of you guys have good reasoning. I can see for either side. Okay. Kate, I like your answer too. Nice. Yeah. I don't know. And in my previous classes, it's all been definitively one or the other side. I'm not going to tell you which side I thought it was initially. Also because it's fun. So hold this in your mind. So there's a difference between effort and amount of work completed. This is the important piece that I want you to get, is that effort does not tell us how much work is done. Okay? Effort doesn't tell us how much work is completed. What I want you to do now is I posted an assignment in first period that is called It's All Uphill. I want you to go to that. And there are 3. First off, what we want to figure out is the relationship between force and distance when we're going up an incline. So now we're going to start looking at physics, okay? We're going to start looking at what work is in physics. So what's that relationship between force and distance? We want to figure that out. To start off, I'm just going to start connecting work and effort to physics. So consider the following situation. We have cars in the diagram are each taking a different path to the summit of the hill. Okay. Notice the path lengths, AD, which we would describe as the least steep path, BD, which would be changing steepness. So not consistent. It gets steeper and less steep. You'll notice that like right where that truck is on the path BD is less steep than AD. And then other points, it's like completely vertical, right? If you've ever hiked on switchbacks, you know that it's not steep for very long or for a long period of time. Then you do a switchback, it gets pretty steep. Then you go back on the straight path, it's less steep. And then the steepest path is CD, are all different. So they all have different path lengths. So I think the lengths would be BD is longest, AD is second longest, and CD is the longest one. If you were going to bicycle, you were going to ride your bike up to the top of this hill, what would be the easiest path to take? Take a moment, decide, and I want you to write your explanation. We're just going to do this all together as a class. So we're going to go through each of these steps. So which path is going to be the easiest to get up and why? Take a moment to fill it in because you're going to turn this in either at the end of the period or at the end of the day. It will be important to fill this out. I should have made a copy for everybody. Take another moment to fill it out on your sheet. Doesn't have to be a long explanation. Is it easiest because of steepness or because of path length or some other reason? All right. Jennifer, could I hear from you? Which path do you think would be easiest? AD, BD, or CD?
I chose AD just based on steepness because I feel like it would be easier to go up a hill that was less steep rather than a hill that's very steep or one that's changing steepness.
Okay. Cool. Olivia, can I hear from you? Olivia? I'm not sure if you're typing. I'll come back to you. Oh, Abby's got an answer. Cool. BD, because it's not all uphill, making it harder for me to go up, but there are level spots where I can gain speed without going. Okay, sweet. Sweet. Has anyone hiked up Mount Eldon? Has anyone gone up? Gabby, is that a steep hike? Sorta. It's would you say it's a difficult hike? 2.5 miles. I got my map of Flagstaff here, and let me see if I can find it. It's got all the elevations and stuff. Let's see if I yeah. Okay, cool. Let me pin my video if you want to pin my video as well. So here are the different levels of steepness, right? You can see the incline. Here is the trail for Humphreys. Here's the trail for Eldon. You'll notice they had a pretty similar initial steepness, but Humphreys levels out over time. This is like the same level of steepness all the way. It's like 45 degrees. What the heck, dude? Even though it's only 2.5 miles, it's a really, really steep, trail. Like I would rather do the Humphreys Trail if I hadn't had a lot of practice, or I don't know, I wasn't in shape, than doing Eldon, because Eldon is lots of steps. It's very, very steep. And I would exert a lot more effort to go up Eldon, like each step, than I would probably Humphreys. So I think Humphreys would be easier, even though it's a longer trail, than it would be Eldon. So I think either AD or BD work, right? If you're thinking of BD as like switchbacks, that's like switchbacks were made to decrease the effort per step, right? It's meant to be easier to hike up mountains and things like that. Or if you're thinking AD just because it's this straight shot and it's not as steep, I think both of those work. But in the end, what we want to think about in terms of ease is the amount of steepness. So if we want the least steep version, the least steep path is going to be the easiest one, right? I ride my bike around town. I've ridden my bike to school. I try to find the least steep version. And going up like Sparrow to school, super steep. Going up the hill from Walmart, very steep. I'm winded. I'm done. Even if like the entire ride was fine, that hill kills me, right? Not easy, harder. Okay. Now, think about how we described work with that one-page hypothetical paper. Okay. Which path requires the least amount of work? Think about the end product, the ending result. If I was grading them on that one-page hiking paper, is one more work than the others, or are they the same? So take a moment, write down your answer, and I would like a reason with it as well. I'll give you until 10:34. Take a guess. Take a guess on which path is the least amount of work, or are they all equal? Right? They're all equally the most and least amount of work. Take another minute, get your answer down and your reasoning. Okay. Can I hear from someone? Which path is going to be the least amount of work?
BD is
BD? Why, Abby?
because you're not taking as much effort. Like if you're walking up it, it would not be so hard because it's not just like straight up. And I thought it was gonna be AD, but then I was like, it's still straight up, but it's not as much of an incline as CD.
Okay.
But even though it's longer, it's not gonna take as much effort.
So, I'm going to get to you in one moment, but I want to respond to Abby. When we were writing the one-page paper, did effort change how much work we got done?
No.
No. Does that change your answer or no?
It sort of does.
Sort of
and
does.
I just hate you right now because like you're making me.
I'm breaking down all the semantics of this word work. I'm sorry. I'm actually, school might be happening. Learning might be occurring. I'm not sure.
You're making me go back on myself.
That's kind of physics.
Yeah.
Dea. Yeah, what's up?
I thought like you can't really choose because it's different for each person. Like if you're a runner or a swimmer or whatever, and you're a sprinter, then doing a distance run is going to be really hard and a lot of work. But if you're a distance runner, then sprinting is not going to be easy, sort of. So it's kind of just what your strengths are.
Yeah. There's a difference there that we're going to get to in a moment, specifically for physics. So something that's been equalized here is that they're all trucks. They're all cars, like the same car. Let me ask, do all the trucks get to the top of the hill? Does it matter which path they take to get to the top of the hill? So our answer here is going to be the same. They all complete the same amount of work. Doesn't necessarily care about the path. We call this path independent, right? Because the path doesn't change our answer. So they all get to the top of the hill. Path doesn't matter. Now, is this actually true, right? We can talk about this. Great. Mr. Z can make you question your definitions. Fine. You can get frustrated with me. But is it actually true? I want to care about whether or not this is actually true. Is the amount of work the same? And how does this relate to our like initial problem? What's the relationship between force and distance, right? So down below, normally we would do this experiment in class. You'd have a force sensor. We do something. I'm going to show you how this works. I'm actually going to erase my drawings. So in class, on our lab table, I would have set up a stack of books for you, usually 3 books tall. 1, 2, 3. And then there would be a ramp that was angled on the books. Okay. On the ramp, you would place your cart. And we want to know the relationship between force and distance. So there would be a specific distance from the bottom of the ramp to where the ramp gets to the top of the books. So we'd want to know this distance. And then the cart would have a force sensor attached to it that would read on vernier. Force sensor, F sensor is what I'll call it for short. And so we would get both force and distance data. We would get 2. We get these 2 sets of data, right? So here we'd have some angle that would give us this distance, right? And as that angle increased, I could actually do it to here, right? So here, the distance, of course, is shorter, right? From here to the top of the books is shorter. But what about the force, right? Here the angle is larger than this angle. So I gathered the force here as well. I wanted to see what happened as I made it steeper, what happened to the force. Now, I would imagine you have an intuition about what that is, but we have data that I took ahead of time that I want you to look at. So which one's the easiest path, Cade? We said that was either AD or BD, kind of depending on your thinking. If you thought BD was like switchbacks, right? Switchbacks are designed to be the easiest to get up to the top of a mountain versus like a straight path that's has the same steepness all the way through. So what I want you to do, or first off, does this setup make sense? Or have we visualized it, or do I need to word picture a little bit more? I read books, but maybe I'm still a science person, so maybe I haven't described it well enough. All right. If you want me to explain it, send me a message. You can be private, and I can go back and re-describe it. So I have given you the weight of the cart and the vertical height of the incline. I've just made it a nice, easy 1 meter. So let's say these 3 books, it's like 1 meter in height, whatever. Yeah, it's real tall. But round numbers are nice. So you have distance data, and you have the force that it takes to pull the cart up at that angle, up that distance. So what I want you to first do is identify force times distance and fill in the data table. Fill in this section here. Okay. Can someone give me the first value?
4.99.
4.99. Second value?
5.02, I think.
5.02. And then?
Is that one also 5.02?
Yeah. I changed my number here just a little while ago, but that works. Cool. So first off, what pattern or relationship do we find between forces and distances up the inclined ramp? So how I'm going to phrase this is, as distance increases, which is reading the table backwards, so we go from 2.37 to 2.9, what happens to our force? Does it increase or decrease? As distance increases, 2.3, 2.9, what happens to the force?
It decreases.
Yeah. So we would say we have a, I'm going to bold this so that, whoops, oh my gosh. We have a negative or inverse relationship. All right. Which makes sense, right? If something's less steep, it's going to take us longer to get up there, right? So because that less steepness means that there's going to be less force, but that's the distance is going to be longer. So as we get steeper and steeper, the distance is going to go down, but we know that as steepness increases, so does the force. So they're as distance goes up, the force is going to go down, right? They're going to be opposite of one another. What about number 2? The weight of the cart times the height of the vertical height to the top of our hill, and the force times the distance. First off, what about force times distance? Are those numbers similar or different? Significantly different? Are those numbers like pretty much the same? Or are they like, no, those are different numbers? What would you say?
They're almost the same, but they're just a little different, just by a few decimals.
Mm-hmm. So when we're dealing with real data, the numbers will never be exactly the same. We do have 2 numbers that come out the same here, but right, this number isn't exactly the same, but it's only off by 0.03 of a value. So I would say these numbers are, yeah. If I took this data, I would say, yeah, we're getting the same number. Little bits of error here and there causing them to be different, but this is actually quite accurate. How does this value compare to the weight of the cart times the height of the incline? Is it the same? Is it twice as much? Half as much? Is there any like simple relationship we could find? Or is there like no relationship? Yeah, these numbers are just completely different. They're not similar at all. Weight of the cart, right, is above here. 5.01 newtons. Vertical height of the incline is 1 meter.
They're really similar.
Yeah. They end up being like the same value. Interesting result. We do not have time to investigate this. Instead, what I'm going to do is I'm going to investigate it in a set of notes that we're going to work on tomorrow and Wednesday. There are 2 more questions. I want you to answer these outside of class. So if you want to, you can answer those real quickly, turn it in, or you can turn it in after class today, but it shouldn't take you too long. What happens if friction forces are a factor? And then using your physics text or the internet, maybe use physicsclassroom.com. type it. Make sure to type in physics definition, because if you don't, you're just going to get the regular old work definition. But yeah, answer those outside of class. In other news, one is I'm going to not have class on Wednesday, Thursday, because I don't like doing 4 days of class in a row. I don't think you guys like doing 4 days of class in a row. Instead, it's going to be asynchronous class. Second point of news. Many of you have asked me, hey, Mr. Z, can we do test corrections? The answer to that is yes, very much yes. So I'll post that either today or tomorrow. You guys can work on that. Remember, if you do want help on any of that or class, sign up for office hours. Office hours are now by sign up, and you need to go to the important class information document on my Google Classroom site. Okay. And then Lord of the Rings is being read today at 12:30. Be there or be Sam Gamgee turned into a toad. I'm doing Gandalf's voice. It's very fun. But I think besides that, I will see you guys next week. Enjoy your one physics classroom week with me.